In this example, we will anti-differentiate tangent multiplied by secant to the fourth. So referring back to our table on integrating tangent to a power, secant to a power, we see that having this power of secant, which is even, so part one of those guidelines suggests that what we should do then is use the power reduction technique where we save a secant squared and rewrite the remaining ones in terms of tangent so that we'll be in an ideal situation to do a u substitution. So to start here, we're going to take the secant to the fourth and we're going to save two of them. So a secant squared term, which in a moment will play our role of du. Then we have a remaining secant squared. So we take that remaining secant squared and we use a Pythagorean identity to write it in terms of tangent. So secant squared is 1 plus tangent squared. And then we have this secant squared left over. So now, as claimed, we're in this ideal situation where if we let u be equal to tangent, du is secant squared. So the secant squared that we left over plays the role of the du, and then everything else in our integrand, those tangent terms, can easily be written solely in terms of the variable u. So this becomes u times 1 plus u squared du. And once again, when we do a substitution using this power reduction technique, we start off with this difficult integral, but after we've done the substitution, we're really into this ideal situation. We have an antiderivative solely written in terms of powers of u. So anti-differentiate here term by term. This becomes 1/2 u squared plus 1/4 u to the fourth plus c. And then we finish by using our substitution to rewrite solely in terms of that original variable x. So each u needs to become a tangent. So 1/2 tangent squared plus 1/4 tangent to the fourth.